Okay, welcome back everybody to another exciting episode of How to Algebra, where today we are solving equations that have different bases. Um, this is probably one of the most important, right next to the log properties that bring down an exponent. We utilize that fact in this lesson today. So we have 4 examples where we are going to use logs to bring the exponents down. And it's going to be awesome. All right, so let's get it. Okay, solving exponentials with different bases. So this is probably one of my favorite techniques. Here are the methods. So the 2 different scenarios is we're going to have an exponential, right? A base that has an exponent. The variable will typically be in the exponent, and we have to figure out somehow of solving for x, right? So you're either going to have an exponential just on one side of the equation, or you're going to have an exponential where it's on both sides of the equation. And in either case, as you can see here from the different methods, feel free and pause the video and read these if you like. But there are a couple different methods. I tend to stick with method 2. Method 2 tends to work in both scenarios. And you're going to, without a calculator, leave your answers exact. And then with the calculator, we can input what we think is the answer and get a decimal. So let's get it. So solve each exponential equation, give an exact answer. And then round to 3 decimal places. I bet. So look, we have number 1, 3 to the power of 4x plus 5 is equal to 547. All right. The variable is 100% in the exponent. So the rule is that I can do anything I want to an equation as long as I do the same thing to both sides of the equation. That's ultimately what it comes down to in algebra, right? Like you got to keep the equation balanced. So I can do whatever I want. There is an excellent property in logs. If the argument has an exponent, then I can bring the argument down in front. And this is probably the most useful property in logarithms, right? This comes up, this particular property comes up all the time in mathematics, particularly the higher level advanced mathematics when logs tend to come up. And this is also true regardless of the base, right? Typically base e, ln, the natural log, is what we tend to use. Now you can use any base you want. Log and or base 10, log base 10 and log base e, i.e. natural log, tend to be the best in my opinion. Particularly ln because it's less writing. Okay, so number 1, it's in the exponent, the variable that is, and we want to bring the variable down. So that means we need to utilize the logarithm property. So natural log, I'm applying the natural log to both sides. So what this is going to do, this is going to bring the exponent out front. Okay. The natural log of 3 is just a number, right? Whatever that number is. Okay, so from this step, we can, a couple different ways you can go about this. You could divide both sides by ln 3. However, the answer towards the end, we want it to be as simplified as possible, meaning only one fraction if need be. But we're going to distribute the ln 3 to each of these, right? I think it'll be a little bit more cleaner. So 4 ln 3 x plus 5 ln 3 is equal to ln 547. Okay, we're going to subtract 5 ln 3, right? Ln 3 is just a number, and it's being multiplied by 5. So 4 ln 3 x, right, times x. It's not, x isn't part of the argument. ln 547 minus 5 ln 3. And then isolating x. So final answer, x is equal to ln 547 minus 5 ln 3 all over 4 ln 3. Okay, this is it's an ugly number for sure. It's not nice to look at. This is exact, right? We got x by itself without using a calculator, so this is exact. Using a calculator, we can approximate this. It's about 0.185 if we round to 3 decimal places like the instructions say. So taking ln of both sides, quick little recap. Take ln of both sides. We bring the power down. Then we distribute the ln, the natural log, to the binomial in this case. And then we start moving everything to the right-hand side, trying to isolate x. See another example. Number 2. Here we have 2 to the power x plus 4 is equal to 3 to the power 5x. All right, we've got a couple x's here, and they are definitely in the exponent. So I want to apply the rule that brings the power down, right, using natural log. So remember that you could use log base 10. I could use log base 2. I could use any log that has any base that I want. Right? Literally. Natural log is typically what I always reach for. Okay, in this case, all the exponents will come to the front. Right, x plus 4, that's the exponent. ln 2 equals 5x times ln 3. Okay, left-hand side, I'm going to distribute the ln 2 to each of these. So this is going to be x ln 2 plus 4 ln 2. Right, ln 2 is just a number. 5x ln 3. Okay, so now that the ln's are all distributed, I want to move all of the x's. Everything that has an x in it needs to go one way, and everything that doesn't have an x will go the other way. So what I'm saying is I'm going to subtract 5x ln 3 from both sides. So I'm going to get x ln 2 minus 5x ln 3 is equal to plus 4 ln 2, right? Because that's still on the left. And this is equal to 0. So, I mean, could you have moved them both at the same time? Yeah, sure, you could have. Meaning I'm going to subtract 4 ln 2 from both sides, right? I mean, it starts to get a little convoluted, right? When you start to do multiple things at once. You do what your strength allows, right? So we're going to get x ln 2, 5x ln 3 is equal to negative 4 ln 2. Okay, so just take a moment to understand what we're doing, right? We're trying to solve for x. So just take note of where x is. Right, we have everything that has an x in it on one side, and everything that does not have an x in it on the other side. Now, in the previous problem, when we had just a single x, we moved x to one side and everything with a log to the right. Here, we have multiple x's. We have 2. And everything with an x has to be on one side. Now, I'm going to start moving things to the right. However, we need to get a single x. So, you probably already can see where this is going. But on the left-hand side, I have a binomial, right? 2 things being subtracted. I need to factor out the x, right? I would say the GCF. But definitely we're going to factor out an x, right? The thing that's common to both is an x. So if I factor out an x, the thing left behind is ln 2, 5, ln 3. Right? The x has been successfully factored out. And now to get x by itself, we have to divide both sides by ln 2. So you may need to watch this a couple of times to understand what's actually happening. But all we're doing is factoring out the x so we can get it by itself. Right? It's actually a pretty interesting thing that we're doing here. So x is equal to negative 4 ln 2 over ln 2 minus 5 ln 3. Right? These are all just numbers, right? They're natural logs. This is an exact answer. If we put this in a calculator, rounded to 3 decimal places is 0.578. So again, we have 2 different bases, and the variables are in the exponent. So right, natural log is the way. So this is going to be, the exponents are going to come down. The whole reason why we chose to use a log. So 2x minus 3 ln 8 is equal to x minus 1 natural log 5. Okay, the natural log is going to distribute in both cases. So 2 natural log 8 x minus 3 natural log 8. This is equal to x natural log 5 minus natural log 5. Okay, again, everything with an x is going to go left. Everything without an x is going to go right. So I'm going to add 3 natural log 8 to both sides. And then I'm going to subtract x ln 5 from both sides. Okay. So we have, putting it all together, 2 ln 8 x minus x ln 5. This is equal to, right, because this is going to cancel, 3 ln 8 minus ln 5, which is on the right. Okay, I'm going to factor out an x, right, because that's the thing common on the left. So an x is going to get factored out. And the left behind part, 2 ln 8 minus ln 5. This is equal to 3 ln 8 minus ln 5. Okay, we got to isolate x, right? So we got to get comfortable dividing by things that look ugly. Okay, here is a opportunity for a hardcore rookie mistake, right? Like, it almost seems like, oh, there's a ln 8 and a ln 5 on top and bottom. Like, this is not, that cannot happen. Just can't do it. Okay, so x is equal to everything that's on the right here. So x is equal to this. And if we want to approximate it, so approximately 1.816. Okay. All right, last example. All right, number 8. Here, the variable is in the exponent, right? 844 is equal to e to the 2 minus 3x. So the variable is definitely in the exponent. However, the base is slightly different. The base is e, which, don't let that stop us, right? Let's stick to the script. Stick to the script. So I want to bring down the variable. So I take the natural log of both sides. Okay, here's a interesting occurrence. Is that anytime, right, anytime ln and e sort of match up, right, I'm taking ln of e. So ln e, like they match up for sure. Like when they touch each other, it's going to be basically 1, meaning that they cancel, right? So in a sense, we just cancel out. Anytime ln touches e from either side, so you could have e, and then the exponent could be ln. This is going to cancel out. So the case that we have, natural log 844, this is equal to, I'm going to bring down the power, 2 minus 3x ln e. So notice ln e, that's going to cancel. It's just 1 right there. They undo each other. So we have ln 844. This is equal to 2 minus 3x. I can lose the parentheses at this point. Subtract 2 from both sides. So ln, what do you think? 842? Can't do it. You can't. When you subtract 2, you can't subtract 2 from the argument, right? The argument is part of the natural log. It's inside the parentheses. Like it's untouchable. So this has got to be 844 minus 2, which is equal to 3x. And then we divide both sides by 3 because we want to isolate x. So final answer, x is equal to the natural log of 844 minus 2 over 3. This is an exact answer. We can approximate this 1.579. All right. So again, quick little recap. Really, when the variable is in the exponent, which in all these examples they were, it's either on one side or it could be on both sides. And in either case, I just use natural log. Like you use the log with the sole purpose of bringing down the exponent in front and then distributing the natural log into each of the exponents, or if it's just one exponent, then that's fine. Factoring out the x when necessary, and then dividing by the part that's left behind after you factor out the x. And then moving all the x's to one side and everything that doesn't have an x to the other side. Well, and then factoring out the x. So combining like terms. So you're grouping together everything with an x on one side and everything without an x on the other, and then factoring out the x, and then dividing by the leftover pieces. That's essentially what's happening. All right, guys. Well, I've had fun. Let's do this again sometime. Like, subscribe, comment, as always. Peace.